This 7th grade are going to be worse.
And then the 6th grade is going to be really bad.
No, 7th grade is going to be the
They have 3 years to mature.
They are tiny and annoying.
Okay? Usually, students as freshmen are naturally immature. Last year's freshman was really immature as well, and they're not so bad this year. Maybe that's because I don't have them in class.
How many sophomores?
No, I only get advanced sophomores that take chemistry.
Okay, so let's say
Biology.
Well, if you take chemistry next year, you still have to do
Yeah,
biology.
you take both.
Oh.
But then next year, you get to be done with science.
Well, it depends. If you're just trying to take the science to be done, or if you want to go on to higher and better things.
But it would also be interesting. Wait, Kramer, we don't have you next year?
What?
Not unless I have given you a recommendation and you want to take chemistry next year.
No, I recommendation.
But to get a recommendation, you need to probably have received an A- or above in physical science.
A what?
But I couldn't tell you.
I failed. A B minus?
Because this class is the introductory to the other classes I teach. And if you have not built a solid foundation in this class, you will struggle in later classes. That's why every year is important in your education. Okay? The years that you waste now will hurt you in the end. Right? The time you waste now will have a greater impact on your future than you will ever imagine. There is no such thing as a neutral solution. Not neutral solution, neutral decision. Every decision either is a positive one or a negative one in life. Okay? And you guys get to choose that. Right? The gaps that you create now will form and hash themselves out later, which will hurt your GPA, which will hurt your ACT score, which will ultimately hurt the amount of money you get for college, which will ultimately hurt how much debt you get when you come out of college, which will also ultimately hurt your marriage when you get into marriage and you have financial strife because you were in debt because you weren't paying attention and focusing when you were freshmen. Then your kids that you will have kids and they will see the marital stress. Potentially it could cause a marital divorce. That will affect your kids and that will affect your kids' kids. Do you think the decisions that you are making now have an effect on your future?
Yeah.
Yes.
Why?
Why do you think that we have messed up families in this culture?
Because of our it's not my trying.
Well, most of it is because they have a spiritual problem. However,
Maybe.
that brightens my day.
Because we're a lot of
Now, I realize what I usually say just goes in one ear and out the other, but that's okay. One day it'll click and you'll be like, you know what? My parents, Mr. Kramer, they actually were kind of smart individuals. I wish I would have paid attention to them when they were saying things. But that probably won't hash itself out until you guys get to college. But if you can hash it out earlier, you'll save yourself a lot of strife. There you go. That was free of charge.
You promised us we'd turn our pennies into gold. Never did that.
You never did.
One of the final stages. Do it.
Yes. What?
Take
You
your
gotta turn our pennies into gold.
I gotta make sure I have the right chemicals.
I'm just joking.
I'm not joking.
Yeah, I have some problems like the same thing they have.
I don't know if I have any gold pennies laying around. Let me see.
I found a $50.
That's not a gold penny.
Just a very large. I got $1 from the snow cone at the fair.
That's it.
Like, here's your change, hand me the biggest quarter.
Here's I turned in my gold pennies for thousands of dollars. So sorry, I don't have any gold pennies.
I haven't any in here. I flung it somewhere.
Because I gotta supplement my salary somehow.
I found it.
I got pennies, dude.
Yeah, but I can color this one silver Sharpie.
That doesn't make it silver.
Yeah, it does.
That's right.
It makes it the color silver, but if I wash that off, it's no longer silver.
Oh.
You can't wash off gold. Not my gold anyways.
And it looks so much like.
Alright, we got like 2 or 3 slides here. We're gonna spend the rest of this chapter, this lesson here, talking about heat in relation to phase changes. What is a phase change, ladies and gentlemen? Gas going to a liquid is one form of a phase change. What do you know about that, Johnny?
Phase change.
I'm glad you could remember the last word that was said. Let's not talk, or I'll put you next to Kamari, who isn't ever talking. So
Okay.
won't have anybody to talk to.
You can talk to me. Thanks, Sydney.
Sorry. I'm gonna put your name on the board here for not for doing all your
She's not
stuff.
going down campus anyway.
Oh yeah.
Why?
You're part of that.
Oh, yeah, blast.
Blast deal.
Fortnite.
What team do you want?
That'd be more fun though, 'cause she's on Stevens.
What are you guys
No, it's
doing?
getting bruised. Oh, what are you guys doing? What, like, we're
I
doing
think the time's like,
Fortnite.
yeah,
we're
it's
doing
like names.
Oh, I don't remember. You're doing Fortnite, but Austin is still the towel. Yeah. I don't remember.
So what are you
We'll go
doing?
over Fortnite.
Well, at the end, we're
Fortnite.
gonna have this big game, and it's gonna be like, we're gonna have like squirt guns and like pool noodles to whack people with.
Wonderful.
Soft fills with
Have a parade for the sound section.
Why
Oh,
didn't we have this last year? This big game.
So where's the llama gonna be?
what about the crab? What about the crab too?
Wait, what last year we got
But
what
is it
too?
gonna be like a
Oh, and they're making Jello for Slurp juice.
That's
amazing.
awesome.
I want some of that.
Great.
Why aren't we in middle
Let's go
school?
to the
Why?
middle
Yeah.
school.
Do you really want to go back there?
It's probably gonna be overrated. You start
Sugar
drinking
for
the slurp
sister?
juice that gets stuck in your throat, you die.
What's the purpose of this slurp juice?
Yeah.
What if you get hit
Yeah,
with a noodle?
yeah, but people.
Your
don't-
health will be down.
Yeah,
You
but,
need
like, they
to
don't
get
know-
back
they
your
don't
health.
know- the other people don't know.
The Jello has really important nutrients that regenerates your health.
Sugar and whiteboard on your chest every time you get shot, you're done. Sugar and diabetes.
Alright, let's talk. Let's talk. Come on, I think you guys got this in. At least you should have with the time I gave you. It says, when thermal energy. What is thermal energy?
Materials that resist the flow of, oh, that's.
What is thermal energy? This test is coming. The sum of kinetic energy.
That's why.
So basically, guys. Okay. So you've got kinetic energy stored up in your particles. Okay. When you add thermal energy or take thermal energy from a material, the temperature usually changes, and the reason why the temperature usually changes is because what is the definition of temperature?
The average
flow.
Average
of the kinetic
kinetic energy. And if you remove thermal energy from something, you're removing kinetic energy. Is that going to make the average go up or down? Down. If the average goes down, the temperature will go down. Okay? So if I take thermal energy from a system, I remove it, the kinetic energy of that system will go down, and therefore the temperature will go down. And the opposite is true. If I have a packet of thermal energy and I give it to Ethan, okay, his average kinetic energy will go up, and therefore his temperature will go up. Okay? Now, it says, usually. What does that imply?
Not always.
Not always. So there is a situation where you give something thermal energy or you remove thermal energy and the temperature does not change. What? My fly's not open.
No, it's not you. That's what I said.
Alright.
What's
Sometimes the temperature does not change. Let's talk about the situation where temperature does not change.
Change.
So if I bring my paintball gun to this Fortnite battle, would that be allowed?
Yeah.
Why not?
You have to keep
They
that.
got that new emoji which spray paints the floor. Can't I spray paint you guys with paintball gun? Paint.
Because anybody can.
I'd be like a nasty
over
sniper.
there.
Did you say the new emoji?
Well, all those kids are hit
You
one
know.
people circle.
Whatever, sorry. Hey, sometimes I speaks.
Yeah.
Spickets. Miss Spickets. I
And
can't
he's
spell out
speaking.
or speak. No speaky español.
Forever.
Speak for us.
Are you playing basketball tonight?
Is there basketball tonight?
I think it's outside.
Outside, it'll be so late.
Oh, you know.
No,
you're
you're
like,
in
we're
church.
going
It's like
outside.
a party.
Right.
What does that
Oh,
mean?
yeah, I'm not
Just like
going
being
to that.
outside and play?
Yeah, so there's like sandball on ice where it'll be bonfires. So is there gonna be any Jesus stuff?
Yeah,
I don't know.
Yeah.
Jesus.
It's the Jews.
I don't know.
Jesus
I mean, in
before
church the other day,
Jesus.
somebody stood in the back and said, "Where's Jesus?"
Wait, were you there for that?
No, I heard that.
Jesus before Jesus.
That was weird. I thought he was gonna pull a gun.
I feel personally attacked.
Pretend Jesus before Jesus.
Yeah, it was weird.
What happened?
I don't know completely. I guess there was somebody in the back of the room protesting that they weren't having a sermon, they were having a jubilate thing or something.
Wait, seriously, that's what he was doing?
What?
What?
Well, they just said he was mentally.
Well, he's not fully all there. Similar to John.
They said
It's a happy drink.
Is it just
It's like a taste.
they said he just they like
Happy
counted
Starbucks,
five,
you-
behind
you
the
latte.
people.
Oh.
So, yeah,
What's gonna be a good
weird
name?
church.
People latte.
Yeah, he goes like,
It's gonna be a happy
I
Starbucks.
heard him on his name. He's like something. He's
Okay. So I've already talked about heat, right?
Yeah.
What's heat?
It's the.
Hey, we got. You guys are. You guys.
Yes.
The balls, you guys are on a roll, guys. You got thermal energy down, you got temperature down, Sydney got heat. Yes, that's good. Okay, heat is the flow of thermal energy. So, in latent heat and in sensible heat, is thermal energy flowing?
Yeah.
Yes. Okay? Thermal energy is flowing in both. Okay? One of them makes sense, the other one is a little more difficult and we have to talk a little bit about. Which one do you think is the one that makes sense? The sensible heat. Here's why it Here's why it makes sense. Okay, it says for sensible heat. Heat energy that, when applied to a system, produces what?
Change.
A temperature change, right? Most of our experience is, if I give you thermal energy, the temperature will what? How? It'll go up, right?
Yeah.
Okay? Or if I take thermal energy from something, what will probably happen? The temperature will go down, right? That makes sense. Okay? But there actually is a situation where, even though you're increasing the thermal energy or decreasing the thermal energy via a flow of heat, the temperature does not change. And that is when latent heat is occurring, and it happens during a phase change. What's a phase change? Okay, so let me give you an example. You probably never have done this, okay? But when you heat up a pot of water, right? As you're heating it up, the temperature changes. Okay? Temperature goes up and then it starts to boil. And it boils at what temperature? 212 Fahrenheit or 100 Celsius or 373 Kelvin.
8.15.
Okay, now listen. While you're boiling that water, if you were to put a thermometer into the boiling water, listen, the temperature would not change. But aren't you still adding thermal energy via the stove? Right? Like, you didn't shut off the stove while it was boiling, did you? Like, you still have the stove on, which means you're still pouring in thermal energy. However, if you put a thermometer in while it was boiling, it would stay at 100 degrees Celsius until all of the water boiled off. Also, if you have a glass of water with ice in it, the temperature of that glass of water will remain at the melting point until all of the ice is melted. So the question is then, if in both cases thermal energy is going in or out, what is this energy doing for latent heat? Because we know what it does in sensible heat. What does the energy do in sensible heat? It causes a temperature change. But it doesn't do that in latent heat. So what does that energy do? Any ideas? It causes a phase change, but what does that look like? No, well, technically. Okay? So, if I'm going from a solid to a liquid, right? Which one's held tighter? Solid. Okay? In order to get from a solid to a liquid, you have to break apart the bonds that hold a solid particle together. That's what the energy is used for. So instead of increasing the kinetic energy of it, it breaks the bonds, creating a liquid. Same thing with going from a liquid to a gas, right? Liquids are, they aren't rigidly held in place, but they're still really close to each other, right? Okay, so there must be something holding them together, correct? Okay, now that's something we will talk about more when you take chemistry. Okay, it's a force that holds a liquid together. In order to get it to become a gas, wouldn't I need to break that force that holds it together? That's what the energy is doing. But it only happens at the boiling point of whatever substance you're dealing with. Okay? So you'll see a temperature increase until it reaches the boiling point, and then it'll stay at that temperature until all of it is boiled. Okay? I don't know if you remember if I've done this at all or not. Actually, I think we only have one more slide left, so I'm going to get you this last slide. Just to make sure. Dang it. Okay, there's 2 more slides. I'm going to get you these last 2 slides, and then I'm going to put a diagram on the board and summarize it all.
Okay.
Got it? Look like it. Look like you got it. So I'm gonna move on to the next one, have you get it in, and then I'm gonna draw a diagram that I want you guys to draw, and we'll talk about all this stuff, put it all together. Got it? Alright. So, I'm going to draw a diagram here. I think it's one you've seen before, but let me know if it isn't. What do I want to do down here? I'm going to draw a heating curve. Does that sound familiar at all?
Yeah.
No. Yeah, I mean, I'm not done yet.
That was one. Does this not ring a bell? Just a no? Yeah. It does ring a bell? Just for you, or? It's a little different? Probably a little different. It might be different.
Well, I'm just confused by the temperature. This is temperature in Celsius, so I guess temperature is pretty water.
That's because it hasn't gotten all the way to the boiling point.
Okay.
And then this would be, basically I'm adding energy over time. So really the x-axis here is the time. Adding a consistent amount of energy over time. Okay? It's how what water would look like if I consistently added energy to it over time. What we would see the temperature do. Strictly based on a few things, we're going to try to break down what each of these locations on this graph represent. Okay? First and foremost, I have two types of heat. What are they? Told you today, the first two types, one makes sense and one doesn't. Latent and sensible, okay? Based on the definition of latent heat and sensible heat, could you define with each part of the graph, like which ones would be sensible heat and which one would be latent heat? Any ideas? the difference between sensible and latent? Yeah?
Well, okay, so, I know the difference, I'm just trying to, okay. Latent heat is when there's a phase change and
Okay.
the temperature does not change.
Okay, so is there anywhere on this graph where the temperature appears to not be changing? Where? This is ACT 101, guys. You don't have to interpret graphs all over on the ACT. Okay? Temperature is the y-axis, energy over time is the x-axis. Is there anywhere on here where we would see no temperature change?
Yes.
Where?
Zero and
Where the slope is 0. So this is latent heat. And this section is latent heat. So, we have just said that latent heat is when a temperature does not change, but we also know that when the temperature doesn't change, it's because we're going through a what? So where do you think those two locations are referring to?
the water freezing.
A freezing point and the boiling point during a phase change. When does water freeze? 0 degrees Celsius. So this is when it freezes or melts. Why do I say freezes or melts?
Because if it's getting warmer, it'll go back
Yeah.
to.
Depends on if I'm adding energy or removing it. When does water boil? 100 degrees Celsius. So this would be boiling, or what's the opposite of that? Starts with a C, ends with an undensing.
And then condensing.
Those are our latent heat sections. Notice, if I start at a really cold temperature, what phase am I in? Okay, so we got ice, right? Got all ice there. Negative 40 degrees. Okay, in order to get it to melt, I would have to first increase the temperature, right? To get it to its melting point. So I'm putting in thermal energy, and I'm seeing what? Temperature change. What kind of heat is that? The one that makes sense. Right there. Sensible heat. You add energy, you see a temperature change. Or you remove energy, you see a temperature change. Then it gets to the point, 0 degrees Celsius, where water freezes and melts. That's when a phase change occurs for water. Okay? So instead of seeing a temperature change, I'm still adding energy, right? Over time. But that energy is not changing the temperature. What is it doing? It's causing it to either melt or freeze depending upon whether you're adding energy or you're taking energy away. That's what it's used for. Okay? So actually at this point, I will have both ice and liquid water. Both. Because the temperature will not change until I have melted everything. As soon as all of the ice is melted and I continue to add energy, then what will you see? I mean, I'm going to have all liquid, but what's going to start happening? The temperature is going to start changing because I have gotten through the what? The phase change. Once I'm through the phase change, now that energy can go back into increasing the temperature. So here I have only liquid. And so I'm adding energy. What I see is the temperature starts rising and rising and rising. Eventually I hit a point where it stops rising. What happens? So first off, what kind of energy or what kind of heat is this? Okay. Get to a point where the temperature will stop changing because that's where I'm going through a different phase change. In this case, I'm going through the boiling phase change or the condensing phase change. So what will happen is the energy will go in to the bond to break the forces or vice versa, and we will see latent heat. So what do I have here? Liquid, gas, solid, bunch of stuff. Liquid and a gas. And here. This is sensible heat. Why? What? Change the temperature. Okay? And I will have only gas. Have you ever heard the phrase, don't pack up and leave yet. Have you ever heard the phrase, steam is more dangerous than liquid water?
Yeah.
The reason why is, the hottest you can get liquid water is 100 degrees Celsius. Because you have to turn it into a gas before the temperature will rise. So gaseous water will do more damage than liquid water ever could. Okay? That's why they say steam is worse than gas. Now stop, one last thing. Okay, I didn't specifically define what latent heat of vaporization and what latent heat of fusion was. That is this location. That's latent heat of fusion. This is latent heat of vaporization. Fusion represents freezing and melting. You might want to write that in your notes. Vaporization represents boiling or evaporating. And the number there tells us how much energy I would need to break apart or to form a liquid. How much energy I would have to do to go through the phase change. Now, last thing. Do you think all things take the same amount of energy to go through a phase change? No. So do you think like the latent heat of fusions for different materials might be different amounts? Yeah. So what you might see with different graphs is this one might be longer in some situations and smaller in others. If it's longer, that means it takes more energy to go through the phase change. If it's shorter, that means it doesn't take as long to go through the phase change. That makes sense? And all materials will have different latent heat values. You may leave. Rockets.
Yes. They want the Warriors.
Although I don't think they have a chance.
What? Are you serious?